Hello and welcome to our mathematics lesson. We continue to dwell on the topic quadratic expressions and algebraic fractions. We are now dealing with simplification of algebraic fractions. During our last lesson, we were able to look at how we can be able to simplify algebraic fractions by addition and subtraction. During this lesson, we want to bring in a new concept on how we can be able to add and subtract to simplify very complex algebraic fractions. So all this will be under the concept of further addition and subtraction of algebraic fractions. To take us back a little, when we were looking at addition and subtraction as ways of simplifying algebraic fractions, we said that there are three critical steps that are involved. The first step is determination of the LCD, that is the least common denominator. Then step number 2, we express each fraction using the LCD that you'll have come up with. Then the third and the last procedure or step is to either add or subtract the numerator. When you're given a good example of x all over 4 plus x over 2, so these are algebraic fractions, you first look for the LCD, that is the least common denominator of 4 and 2, that will be 4. 4 goes into 4 once, 1 times x will give us x, plus 2 goes into 4 twice, 2 times x will give us 2x. Then we now add the numerators, and that will give us x plus 2x, which will be 3x all over 4. So you express this is the same as x over 4, 2x over 4. So you have expressed the fractions as or using the LCD. Then you finally add or subtract the numerators. But what about now when we are given very complex algebraic fractions? Like we are given 2x subtract 1 over 3 plus or minus x plus 4, all these divided by 4. Or even another much complex expression, 2 all over x plus 3 minus 5 into x plus 3 squared. So these are high levels algebraic fractions that we are supposed to be able to simplify by further addition and subtraction. What are we supposed to do in such case or during such cases? Now there are a number of steps that are involved whenever you want to solve such problems. First, we shall say, whenever you want to combine these algebraic fractions, there are a few things that you need to recall. So when combining algebraic fractions, that involves subtraction sign, that involves subtraction signs. Recall that. So whenever we have a negative or a subtraction sign opening up a bracket which consists of a positive or a negative number, what is this that we must be able to recall concerning such? 1, and it's very important, 1, product of two numbers of opposite sign is a negative number. Example given, if you have negative 2 multiplied by positive 2, the signs are different. This will give us negative 4. So the answer or the result is going to be a negative number. Number 2, product of two negative numbers. Product of two negative numbers is a positive number. Example given, if we have 5 into 1 subtract x all over 8 minus 2 into x subtract 1 all over 8. So we understand that the LCM of 8 and 8 is going to be simply 8. But now when we'll be expanding this will be 5 times 1, which is going to give us 5. 5 is a positive times a negative, will give us a negative number, so minus 5x. We move on to this. This is minus 2 multiplied by x, will get negative 2x. Minus 2 multiplied by minus 1. You get a positive number, which is positive 1. Another thing that we need to understand is that sometimes the denominator can be a binomial product of the two terms or the two denominators of that particular fraction. That is, a common denominator can be a product of two bimodal or binomial terms. Example given, if you have 2 over x plus 3, and then this is being added to 3 all over x subtract 1. So you'll discover that the denominators are not the same, and again each one of them does not consist of a factor of the other term. So in this particular case, the common term is going to be a binomial product of the two terms. That is, you simply take this terms times this term, and that will be x subtract 3 multiplied by x subtract 1, and then that will be of course 2 into x minus 1 multiplied by 3, or added to 3 into x subtract 3. So we're going to look at a good number of examples on how we can be able to further use these instructions in solution or in simplification of algebraic fractions by further addition and subtraction. Example 1. we are told simplify the following. We have got a, which is x minus 1 over 3, subtract x plus 4 all over 5, b, 2x minus 3 over 6, subtract 3, subtract x all over 5. So let us solve these two. You have been told to simplify x minus 1 all over 3, subtract x plus 4 all over 5. So again, in this case, the procedure still remain the same, that those of expressing these two fractions using the LCD. The LCD, or the least common denominator of 3 and 5, is going to be a product of these two numbers, which is 3 multiplied by 5, which is going to be 15. And 3 goes into 15 5 times, so that means we must multiply the numerator by 5, and this will be x 5 into x subtract 1 all over the new denominator, which is 15. We subtract 5 goes into 15 3 times, that means we must multiply our numerator by 3, and this will be 3 into x plus 4, all these divided by the new denominator, which is 15. The next step involves opening up the brackets or expanding, and when you expand, this will give us 5x less 5 over 15. Subtract, we open this will be minus 3 times x, which will be minus 3x, minus 3 times positive 4, that will be negative 12. The whole of this is divided by 15. We now have all of them under one denominator, which is 15. Then we now move in and simplify by combining the like terms. 5x minus 3x is 2x, minus 5 minus 12 is minus 17. All this divided by the new denominator, which is 15. So you can be able to see, first we look for the LCD, that is the least common denominator. Then we express the two fractions using the LCD. Then you now move on to subtract, and for you to subtract you have to expand or open up the brackets. You should be very careful of the sign outside the bracket and the sign inside the bracket. If you have a negative multiplied by a positive number, the result is a negative number. If you have a negative multiplied by another positive, the result is a negative number. Number B, we are having 2x minus 3 over 6, subtract 3 minus x all over 5. Now the LCD in this case is going to be 6 by 5, which is going to be 30. Now we seek to now express these two expressions using the new denominator, which is 30. 6 goes into 35 times, so that means we multiply the numerator by 5. This will be 5 into 2x minus 3 all over our new denominator, which is 30. We subtract 5 goes into 36 times, that means we multiply the numerator by 6. This will be 6 into 3 subtract x all over the new denominator, which is 30. So we now therefore finally subtract or add, and in that case we need to expand our brackets. So 5 multiplied by 2x is 10x, 5 multiplied by negative 3 is minus 15, Minus 6 multiplied by 3 is minus 18. Minus 6 multiplied by minus x is positive 6x. You can now be able to appreciate that whenever you multiply a negative and a negative number, the result is going to be positive. Then we finally combine the like terms and either add or subtract. So 10x is like to 6x, so 10x plus 6x is 16x. Minus 15 minus 18 will give us negative 33. And this will be divided by 30. So we look for the LCD, express the two fractions in terms of the new denominator, then move in and add or either subtract. But before you do that, you must expand, and whenever you expand, take note, positive and a negative will give you negative. Negative, positive will give you negative. Negative, negative will give you a positive. Of course, positive, positive goes without saying that the result is going to be a positive number. Example 2. Simplify the following. One 4 over x plus 1 added to 3 all over x minus 2. Part B, 3 all over x minus 1, the whole of it is squared, subtract 2 all over x subtract 1. So we now need to solve this particular part where we are having 4 over x plus 1 added to 3 all over x plus x minus 2. Now before we are able to solve this, we need to get the LCM of these two numbers. It will really give you a headache if these two numbers or these two denominators are not alike. And as you can be able to see, we have x plus 1 and x minus 2. But the introduction should be able to clarify and eliminate that particular worry. We said at some cases, we might have the denominator or the LCD being the product of the binomial denominators. That simply means you take the product of these denominators to be your LCD. So your LCD is going to be x plus 1 multiplied by x subtract 2. It's a binomial product. So we therefore need to proceed and look at how this is now going to look like. So in our, we seek to express these fractions as or using this new denominator. X plus 1 goes into x plus 1 into x minus 2. It will cancel off with this, leaving you with x minus 2. So that means we multiply this 4 by x minus 2. So we're going to have 4 into x subtract 2 over the new denominator, which is x plus 1, x minus 2, added to x minus 2 goes into x plus 1, x minus 2. It will go off with that, leaving you with x plus 1. So x plus 1 multiplied by 3, this will give us 3 into x plus 1 over the new denominator, which is x plus 1, x subtract 2. You'll still discover that when you decide to cancel off, you still retain your 3 over x plus 2. You'll still retain your 4 all over x plus 1. We now need to move in and solve, and this will be under now one denominator, which is x plus 1, x minus 2. We expand the numerator, and that will be 4x minus 8 plus 3x plus 3. Then you can now proceed and collect the like terms together. 4x plus 3x will give us 7x, minus 8 plus 3 will give us negative 5. All this divided by the binomial denominator, which is x plus 1, x subtract 2. So we have been able to simplify the whole of this down to one expression. If we look at our second example, we are having 3 all over x minus 1 raised to 2, 2 all over x minus 1. This one is quite easy because whatever is inside the bracket is the same or are like terms. And if they are like terms, then that means we can be able to take the highest term, and the highest term is going to be x minus 1. That means that our LCD is going to be x subtract 1 raised to power 2. Then we now seek to express these two particular fractions in terms or using the LCD, which is x subtract 1. Now x subtract 1 squared goes into x subtract 1 squared once. So we take that 1, we multiply by 3, and this will give us 3 over the new x minus 1 squared denominator. Subtract. X minus 1 goes into x minus 1 squared, x minus 1 times. So that means we're going to have 2 multiplied by x minus 1 over the new denominator, which is x minus 1 squared. So we now rewrite it off. That is x minus 1 squared. This will be 3 subtract 2 multiplied by x is 2x, added to negative 2 multiplied by 1 is 2, and 3 added to 2 will give us 1. So this is going to be 1 subtract 2x, all this divided by x subtract 1 squared. So our answer is going to be 1 minus 2x all over 3 plus 2 will give us 5. So this will be 5 minus 2x all over x minus 1 squared. Example 3. We are told expand the following. One, negative 2 into x plus 3. Number B, negative 10 into 3 subtract 2x. And number C, negative 16 into 1 subtract 4x. It is very important for us to know how to expand before we proceed, so that you know the playing between negative and positive numbers and what happens when we have a product of different signs and the product of the same signs. So in this case, we are having negative 2 into x plus 3. We need to expand, and in expanding, the term that is outside the bracket is used to open up the bracket. So like in this case, we are supposed to open x plus 3 using negative 2. So that means whatever is outside the bracket is multiplied into every term inside the bracket. So this will be negative 2 multiplied by x, which will give us negative 2x. Minus 2 multiplied by positive 3 will give us a negative number, and that is negative 6. It's just as simple as that. It ends there. Number B, we are having negative 10 into 3 less 2x. We are again going to multiply the term outside the bracket to the term inside the bracket, that is 3 minus 2x. Minus 10 multiplied by 3 will give us negative 30. Negative 10 multiplied by negative 2x. First, because negative and negative is going to give us a positive, so that will be a positive. 10 times 2x is 20x. So we only want to see the play of the positive and negative sign. Lastly, number C, we have negative 16 into 1 minus 4x. Still is quite the same as this. So negative 16 multiplied by 1, you'll get negative 16. Negative 16 multiplied by negative 4. Now note that the number is changing, so that we have 16 multiplied by negative 4. That will give us a positive number, which is 64x. Another example, example 4. We are told write the LCD of these pairs fractions. It's also important to recall how can we both find the LCDs. That's a third and 5/9. Number B, 3 over x and 5 over x squared. Number C, 4 over 2x minus 1 and negative 1 over 4x x minus 4. It is again very important for us to be able to know how we can be able to find the LCD, that is the least common denominators of particular fractions. Now in this case, we simply need to find the LCM of 3 and 9, which are the denominators. And the LCD, or the LCM of 3 and 9, the least number that can go into either 3 and 9 is 3. 3 goes into 3 once, it goes into 9 3 times. 3 goes into 3 one time, and this will leave us with 3 multiplied by 3, which is going to be 9. So that means that the LCD here is going to be 9. We had also agreed that whenever we have two denominators where one factor or one of the number is a factor of the other, then you pick the highest number to be the LCD of those particular fractions. Like in this case, 3 is a factor of 9. Therefore, you simply, instead of coming up with a table, you simply check or pick up the highest factor, which is 9. In this particular case, you can be able to pick the highest factor, which is x squared. And therefore, in this case, you can be able to say that the LCD of x and x squared is going to be x. Or still, you can still come up with your table where you have x and x squared. The first term will be x, that will be 1, that will be x. The next term will be x, this will be 1, this will be 1. This will give you x times x, which still will give you x squared. Now this is a case where we are having two numbers in the denominators that are not like terms. And now in this particular case, for you to have obtained the LCD, you get what we call the binomial product of the denominators, and that will be 2x minus 1 multiplied by x minus 4. That will be your LCD. Example 5. Simplify the following. Number 1, we have x plus 3 over 4 minus x plus 2 over 3. Part B, x minus 1 over 3 subtract x plus 3 over 5, and C, x minus 4 over 3 x minus 4 over 3 minus x plus 1 over 6. So we need to solve or simplify these three algebraic fractions. Now in the first case, we need to obtain the LCD of 4 and 3, and you'll discover that the least common denominator is going to be 4 multiplied by 3, which is 12. Now 4 goes into 12 3 times. That means we multiply the numerator by 3, and this will be 3 into x plus 3. You divide by the new denominator, which is 12. We subtract. 3 goes into 12 4 times. That means we multiply 4 by x plus 2 over the new denominator, which is 12. So when you rewrite now using our new denominator and you expand that, you're going to have 3x plus 9 minus 4x minus 8. Minus and positive, minus and positive, all of them are going to be negative. So in this case, we now finalize by looking at this. 3x minus 4x is minus 1x. Positive 9 minus 8 is 1. So this will be 1 minus x, all of it divided by 12. It is good to always begin with a positive number. So that's why I've begun with 9 minus 8, which is 1, then 3x minus 4x, which is negative x. Then we divide by the common denominator, which is 12. Understand that the procedures are quite simple. Look for the LCD. Rewrite each of the fractions using the new denominator, then either open up the bracket, and when you're opening up the bracket, recall that whenever you multiply different signs, the result is going to be a negative number, and whenever you multiply two negative numbers, the result is going to be a positive number. The LCD here will be 3 multiplied by 5, and this will give us 15. Now 3 goes into 15 5 times, so that means we are going to multiply our numerator by 5, and this will be 5 into x subtract 1 over the new denominator, which is 15. Subtract 5 goes into 15 3 times, so that means you multiply this denominator by 3, and that will be 3 into x plus 3 all over the new denominator, which is 15. This will give us the denominator, which is 15, and you expand the brackets. This will be 5x subtract 5 minus 3x, still minus 9. Then you finally move in and do the addition and subtraction. So 5x minus 3x, this will give us 2x, minus 5 minus 9, that will give us minus 14. All of this divided by 15. Again, we look for the LCD. Rewrite each of the fractions using the new denominator, then add or subtract. Negative and positive gives us a negative, negative and positive gives us a negative. Example C, we are told x minus 4 over 3 subtract x plus 1 all over 6. We need to find the least common denominator, and the least common denominator of 3 and 6 is going to be 6, because 3 is a factor of 6. So that is 6. Then we now seek to rewrite these fractions using 6 as the denominator. Now 3 goes into 6 twice. This will leave us with 2 into x minus 4 all over the new denominator, which is 6. Subtract. 6 goes into 6 once, so that will be 1 multiplied by the numerator, which is x plus 1, all over the new denominator, which is going to be 6. We now rewrite them under one denominator of 6, and that means we expand each of the brackets. This will be 2 multiplied by x, which will give us 2x. Subtract 2 multiplied by negative 4, that will be minus 8. Subtract 1 multiplied by x, that will be x. Subtract negative 1 multiplied by negative 1, which will be negative 1. We now move on and combine the common factors or the like terms. 2x minus x will give us x. Minus 8 minus 1 will give us minus 9 all over the new denominator, which is 6. We now want to consider cases where we have a negative sign and see the playoff between negative sign and a negative sign under example 6. In example 6, we are told, simplify the following. Number 1, we have x plus 5 over 3, subtract x minus 1 over 2. B, we have x minus 4, all of it divided by 5, subtract x minus 6, all of it over 7, and finally C, we have 3x minus 7, all of it divided by 4, subtract x minus 1, all over 2. We now want to solve these 3 problems or simplify them by further addition and subtraction. We are going to find the LCD of 3 and 2, and because there is no common term, we are going to multiply the 2, that is 3 by 2, and that means that the LCD is going to be 6. Then we now rewrite these fractions using 6 as the new denominator, and 3 goes into 6 twice, so that means we're going to multiply our numerator by 2. So that will be 2 into x plus 5 over the new denominator, which is 6. Subtract 2 goes into 6 3 times, so that means we multiply our expression by 3. That will be 3 into x subtract 1, all this divided by 2. We now divided by the new denominator, which is 6. We now combine them under one denominator, which is 6, and that means we expand each of the brackets. During expansion, this will be 2x, 2 by 5, that will be 10, negative 3 by x, that will be negative 3x, minus 3, negative 3 multiplied by negative 1, now that is going to give us positive 3. So when we add 2x minus 3x will give us negative x, 10 plus 3 will give us 13. So this will be 13 minus x all over 6. I've preferred to begin with a positive number since 2x minus 3x is minus x and 10 plus 3 is 13. Number B, the LCD of 5 and 7 is going to be 35. We now seek to rewrite these particular expressions or these fractions using the LCD as 35. 5 goes into 35 7 times, and that means you multiply the numerator by 7, and that will be 7 into x minus 4 all this divided by 35. Subtract 7 goes into 35 5 times. That means we multiply 5 by x minus 6 divided by the new denominator, which is going to be 35. So in writing them under one denominator of 35, we now seek to expand each of the brackets. That will be 7 by x, which will give us 7x, 7 by 4, which will give us 28, minus 5 times x will give us minus 5x, minus 5 times minus 6 will give us positive 30. 7x minus 5x will give us 2x, minus 28 plus 30 will give us 2. All this divided by 35, which is our new denominator. So the main point of to be of concern is the negative, how it plays us off with another negative. Lastly, we have got 3x minus 7 over 4. All this subtract x minus 1 all over 2. Now the LCD is going to be 4. We now seek to rewrite those fractions using the LCD as 4. 4 goes into 4 once, so that means we multiply 1 by 3x minus 7. We'll still have 3x minus 7 over the new denominator, which is 4. We subtract. 2 goes into 4 twice. That means we multiply x minus 1 by 2 all over the new denominator, which is 4. In writing this under one denominator, this will be 3x minus 7. We expand the other expression. This will be minus 2x plus 2. Since minus and minus will give us a plus or a positive. Then we collect the like terms. 3x minus 2x is 1x. Minus 7 plus 2 is minus 5 all over the new denominator, which was 4. Example 7, we are told simplify the following. One, 3 over x minus 1 added to 4 over x plus 1. Part B, 5 over x plus 4 added to 12 over x minus 3. Then part C, 3 over x minus 2 added to 4 over x plus 3. Now you can be able to see that for you to be able to find the LCD of all of these terms in example 7 is that we require what we are referring to as the bimodal products, or the product of the two binomial terms. That is, in this case, if you want to get the LCD, it's going to be the product of the binomial terms, which is, in this case, the LCD is going to be x minus 1 multiplied by x plus 1, because they are not the same. Then we rewrite now the two fractions using the new denominator. X minus 1 goes into x minus 1, x plus 1. It will cancel off with this, leaving us with x plus 1. So that means we multiply the numerator with x plus 1. This will be 3 into x plus 1 plus x plus 1 goes into x minus 1, x plus 1. It will cancel off with this, leaving us with x minus 1. So that will be 4 into x minus 1. And then remember, each of them is divided by x minus 1, x plus 1, which is the new denominator, x minus 1, x plus 1. So when you write them under one denominator, this will be x plus 1, x minus 1. We open this will give us 3x plus 3 plus 4x minus 4, which will give us 3x plus 4x to be 7x, 3 minus 4 to be minus 1, all over the new denominator x minus 1, x plus 1. So just like how we were solving the others, the only difference is that this one requires us to find the product of the two binomial terms. The same is going to happen here, where the LCD is going to be x plus 4 multiplied by x minus 3. Then we rewrite these expressions, or these two fractions, using the new denominator. X minus 4 into x plus 4, x minus 3, it will cancel off with this part, leaving us with x minus 3. That means the numerator will be 5 multiplied by x minus 3 over the new x minus 3. We add it to x minus 3 goes with this, leaving us with x plus 4. That means we multiply 2 with x plus 4 over the new x plus 4, x minus 3. So when we write them under one denominator, x plus 4, x minus 3, and we expand this, that will give us 5x minus 15 plus 2x plus 8. Now 5x plus 2x will give us 7x minus 15 plus 8 will give us negative 9, will give us negative 7. So that will be minus 7 over x plus 4, x minus 3, which is our new denominator. Lastly, but not the least, we have 3 all over x minus 2 added to 4 all over x plus 3. Now the LCD in this case is going to be x minus 2 multiplied to x plus 3. Now we now seek to write these fractions as equivalent fractions consisting of this new denominator. X plus 2 goes into x minus 2 goes into x minus 2, x plus 3. It cancels off with that, leaving us with x plus 3. So we're going to have 3 multiplied by x plus 3 over the new denominator, which is x minus 2, x plus 3, added to. Now x plus 3 goes into x minus 2, x plus 3. It cancels off with this, leaving us with x minus 2. And that means we're going to have 4 into x minus 2 over x minus 2, x plus 3. So when we write this under one denominator, x minus 2, x plus 3, then we expand the numerator, we're going to have 3x plus 9 plus 4x minus 8. 3x plus 4x will give us 7x. 9 minus 8 will give us 1 all over the new denominator x plus 2, x plus 3. So that's how they can be solved. Example 8. We are told to simplify the following. We are having 4 all over x plus 1 squared, subtract 3 all over x plus 1. Then 2, we are having 3 x minus 2 added to 4 all over x minus 2. That one is squared. So we need to solve these two, and for us to be able to identify the one that's going to be our LCD, our LCD is going to be the highest factor. And in this case, the highest factor is x plus 1 squared. So we now rewrite these expressions using x plus 1 squared as the new denominator. So x plus 1 squared goes into x plus 1 squared once, so that will be 1 multiplied by 4. That will be 4 all over x plus 1 squared. Subtract. X plus 1 goes into x plus 1 squared, x plus 1 times. So that means we are going to have 3 into x plus 1 divided by x plus 1 squared. So written under one denominator, this will be x plus 1 squared. Then this will be 4, subtract 3x, subtract 3. So when we finally simplify, 4 minus 3 is 1. So we shall have 1 minus 3x all over x plus 1 squared to be the answer to this particular question. Number B, we have 3 all over x minus 2 added to 4 all over x subtract 2 squared. Now the LCD in this case is going to be the highest term, which is x minus 2 squared. Now x minus 2 goes into x minus 2 squared, x minus 2 times. We multiply 3 by x minus 2, that will be x into x minus 2 all over the new denominator, x minus 2 squared, plus x minus 2 squared goes into x minus 2 squared one time. So this will be 4 multiplied by 1 divided by x minus 2 raised to 2, which is the highest power. So when we write them under one denominator, this is going to be x minus 2 squared. We open up the bracket. This will be 3x, subtract 6 plus 4. So this will give us 3x minus 6 plus 4. This will be minus 2 divided by x minus 2. The whole of it is squared. We now want to reconsider our last example in this particular question, example 9. Where we were told that one of the most common errors made while subtracting algebraic fractions is hidden in the working shown below. We are having 7x over 2 subtract x minus 2 all over 5, and that this equals to 35x over 10 minus 2 into x minus 2 over 10, which gives us 35x minus 2x minus 4 all over 10, which finally gives you that 3x minus 4 all over 10. The question is 1. What error or what is the error in and in which step was it made? Number B, give the correct answer. Now we have been told that there is a common error that most students or most mathematicians normally commit whenever they are subtracting fractions. And we have been given here an example where that particular error has been hidden. we had 7 over x minus 2, subtract x minus 2 all over 5. So this one were made into equivalent fractions, and for you to have made them into equivalent fractions, we look for the LCD of 2 and 5, which is 10. Then you express each of the fractions as, or using 10 as the denominator. So this one gave us that 5x over 10 minus 2 into x minus 2 all over 10. Up to here, everything or both the two fractions are okay. Now when they were being made under one denominator and we now expanded, so this was 35x minus 2 times x will give you minus 2x, that is okay. Minus 2 multiplied by minus 2, minus and minus is supposed to give us a positive. So we have identified where the problem was. So, and that error is they forgot that when you multiply a negative and a negative, the result is going to be a positive. So here it was supposed to be positive 4. In which step? It was on the second last stage, that is during the opening of the bracket. Now give the correct answer. That will be that 5x minus 2x plus 4 all over 10, and this will have given us that 5x minus 2x, that will be that 3x plus 4, all these divided by 10. Now that brings us to the end of our discussion on how we can further simplify algebraic fractions by addition and subtraction. Next time when we meet, we are going to look at equations that involve algebraic fractions. Thank you.